Canon Virtual Production System workflow. In this video, we'll walk through a practical virtual production workflow using the Canon Virtual Production System, CVPS for short. This time, we'll cover the system configuration, network setup, and nodal offset calibration. The workflow applies to both LED wall and green screen virtual production. To shoot using virtual production, you typically need three core components: a camera tracking system, and a rendering workstation to produce the background image and the composite image. In this configuration, an EOS C400 sends the video feed, CV metadata, sync signals, and tracking data into a single PC. Lens data, such as focus and zoom, is acquired through the RF mount and transmitted from the camera's Ethernet terminal to the PC as CV metadata. At the same time, the tracking device sends camera position and orientation data to the PC. The PC then combines the video signal, lens metadata, and camera tracking data and applies them to the final composite output. A sync generator provides a reference signal to the camera, the tracker, and the PC, keeping frame timing locked across the entire system. Next, let's look at the network setup. Building the network between the camera and PC is one of the most critical steps to getting CVPS up and running. Connect the EOS C400 and the PC via Ethernet and place them on the same network segment. This allows the PC to receive the CV metadata, including camera and lens information, that is output by the EOS C400. For on-set virtual production, use static IP addresses rather than DHCP to avoid latency issues, IP conflicts, and other network-related problems. A network administrator should assign IP addresses for each device. When setting static IPs, it's essential that all devices share the same subnet mask. If network segments don't match, devices won't communicate properly, one of the most common causes of connection trouble. Here's a sample configuration. Go to the Network menu and enter the IP address and subnet mask. Set the IP address and subnet mask to match the same subnet. Finally, confirm that the Live Link plugin for Unreal Engine is receiving camera and lens data from the EOS C400. If metadata values display correctly and update in real time, your network and IP configuration are set up properly. Last, let's cover nodal offset calibration. In virtual production, the real camera's point of view must match the virtual camera's point of view in the virtual CG environment. The process of correcting any mismatch between those viewpoints is called nodal offset. Because tracking sensors and markers can't be mounted exactly at the lens's entrance pupil, there will always be an offset between the tracker's origin point and the camera's true viewpoint. In this footage, you can see the sensor unit mounted on top of the camera, clearly not in the same position as the lens viewpoint. That physical offset must be accounted for, so the live-action image and CG align precisely without parallax errors. There are a couple common ways to do this. Physically measure offsets with a measure and input the calculated values into the rendering software. Another approach is to use dedicated calibration software to automatically measure offsets. CVPS links camera and lens information in real time as CV metadata, removing the need for that pre-calibration process and dramatically cutting prep time before shooting. Once the nodal offset is applied, the virtual camera will track correctly with the real camera's movement, enabling natural, parallax-free composites. This concludes our CVPS workflow overview.